You know, you've probably never experienced true height. And I'm not talking about the view from a skyscraper or even the peak of a modern mountain. I'm talking about the incomprehensible verticality of a world that has been turned completely upside down. We're going to dive into a massive planetary scale investigation. Let's start by picturing the most extreme, desolate environment on our planet. Imagine standing right on the jagged, snow-whipped summit of Mount Everest. The wind is howling, it's just a place of immense, sobering power. Picture standing exactly 29,032 feet above sea level. This is a lethal altitude. The air up here is so agonizingly thin, it simply cannot sustain human life for very long. The temperature, a permanent, brutal freeze. It's the absolute highest point on the Earth's crust, literally brushing against the stratosphere. But if you were to look down at the rock beneath your heavy climbing boots, you would find something absolutely impossible.
That rock right beneath your boots is the Cumulangma Formation. It's a type of limestone. And embedded right there, frozen in the stone at the literal roof of the world, are the fossilized remains of ammonites, brachiopods, and crinoids. These are creatures that once lived, breathed, and swam in a warm, shallow tropical sea. So the rock holding you up at over 29,000 feet is actually a cemetery for the deep ocean.
So it begs the ultimate question, right? How exactly did the bottom of a tropical ocean end up at the absolute highest peak on Earth? This isn't some poetic metaphor, it's physical reality. In this explainer, we're going to use forensic geological tools to reconstruct the violent death of a completely vanished ocean. We're going to read the record written in the stone to understand how the map of our world was violently redrawn.
To solve this colossal crime, we've got to look at our victim, the Tethys Ocean.
We have to travel back about 250 million years. Picture the ancient world. It's dominated by the massive supercontinent Pangaea. Cradled right in its eastern embrace was this incredible body of water, the Tethys Sea. Named after the Greek goddess who mothered the world's rivers, the Tethys was a vast, wedge-shaped tropical ocean. It literally cut right into the global landmass like a giant, gaping mouth straddling the equator.
And the Tethys wasn't just a big body of water. It was an absolute planetary climate machine. Because it stretched east to west across the equator, it allowed a continuous warm current to flow right around the globe. This was basically a planetary conveyor belt of heat that kept the equator and the poles relatively close in temperature. It maintained that lush, Mesozoic greenhouse state where the dinosaurs thrived. Plus, it was a massive limestone factory. Its sunlit margins were totally supersaturated with calcium carbonate. Over millions of years, it churned out kilometer-thick layers of shells and reef material. The factory floors of this ancient ocean would actually eventually be lifted up to form the stunning white cliffs of the Alps and the massive limestone plateaus of the Middle East.
But a machine that massive doesn't just disappear quietly. This brings us to the perpetrator of our planetary crime in what is basically a continental hit and run.
The murder weapon here was sheer, unstoppable momentum. Around 100 million years ago, the island continent of India snapped off from the southern landmass of Gondwana, and it just started racing northward toward Asia at an astonishing speed of 15 centimeters per year. Now, I know 15 centimeters might not sound like a big deal to you and me, but in plate tectonic terms, that is literally a runaway freight train.
As India surged forward, the Tethyan seafloor caught in its path faced two violent outcomes: subduction and abduction. Subduction was the main weapon. This is where the heavy, dense seafloor is forced down beneath the incoming continent and just completely swallowed into the Earth's fiery mantle. Abduction, on the other hand, is when fragments of that seafloor are violently scraped off the top and thrust upward onto the dry land. Subduction consumed almost the entire Tethyan plate.
Now you might be wondering, how do we actually prove an entire ocean was swallowed into the Earth? Well, we use something called seismic tomography. Think of this as a giant geological CAT scan. By measuring how seismic waves travel through the deep earth beneath the Himalayas, researchers have actually located these ghostly slabs of cold, dense rock that are still slowly sinking toward the Earth's core. These are the sunken corpses of the Tethys seafloor that disappeared over 50 million years ago. We can literally still see the body.
But remember, abduction? Not all of the ocean got swallowed up. Let's investigate the fragments that miraculously survived the collision, the fingerprints in the rock.
Geologic detectives look for these things called Ophiolites. They are basically massive slices of ancient oceanic crust in the underlying mantle that were violently scraped off the subducting plate and preserved up on dry land. This is absolutely crucial physical evidence.
In places like Oman today, you can literally stand on a 20,000 square kilometer continuous slice of the former Tethys seafloor.
There's this quote that just hits the nail on the head. These are the crime scene fingerprints, physical proof that what is now a desert mountain was once a deep sea abyss. I mean, just imagine reaching out and touching a dark greenish rock with these rounded pillow structures. You are literally touching 90-million-year-old pillow basalts that originally erupted at a mid-ocean ridge at the bottom of the sea, and now they're just baking under a desert sun. It's completely mind-blowing.
The true violence, however, happened when the ocean finally ran out of room entirely. This was the hard collision.
Okay, so fast forward to about 50 million years ago. The last of the oceanic crust between India and Asia was gone. The soft collision was over. Now it was continent versus continent. And here's the thing about continental crust. It is super buoyant. It just straight up refuses to sink into the mantle. So when these tectonic heavyweights, India and Asia, finally slammed together, the landmasses just crumpled, folded, and buckled. All those seafloor sediments, the accumulated remains of millions of years of marine life from the Tethys, were squeezed in a massive planetary vise. They had absolutely nowhere to go but straight up, thrust 29,000 feet right into the freezing atmosphere.
And that brings us to this dramatic, perfect realization. Everest is not just a mountain. It is the tombstone of an ocean. That is exactly why you find seashells sitting at the absolute roof of the world. They didn't climb up there. The earth beneath them was violently shoved into the sky.
So, the Tethys might be dead, but its destruction is intimately connected to your everyday life right now. Let's look at the legacies of a dead ocean. The Tethys left behind two massive, world-altering legacies. First, the legacy of wealth. Down in the restricted, oxygen-poor basins of the deep Tethys, dead deep-sea plankton didn't rot. It just piled up, got buried, and was slowly cooked by geothermal heat into hydrocarbons. Today, that exact region contains roughly 70% of the world's current oil and gas reserves. Every time you drive a gas-powered car, you are literally fueling human civilization with the distilled biological remains of this lost ocean. But then, consider the legacy of climate. When the Tethys closed, that warm global equatorial current we talked about, it was severed. The Earth began to cool down. Furthermore, as the Himalayas were thrust into the sky, all that fresh rock was exposed to rain, causing intense chemical weathering. This process actually pulled massive amounts of carbon dioxide straight out of the atmosphere, locking it away. The death of the Tethys quite literally put the Earth into a deep freeze, setting the stage for the ice ages, which, are the very climate conditions that forced human evolution and birthed our species. So, we pretty much owe our modern civilization and our very evolution to the death of this sea. But if we zoom out to a planetary scale, we see a really humbling truth. The cycle just continues.
Tectonic dominance is a total illusion. Permanence is a fantasy. Let's just trace this relentless timeline. 250 million years ago, Tethys reigned supreme over Pangaea. 100 million years ago, its death warrant was signed as India started racing north. 50 million years ago, the hard collision built the Himalayas and buried the sea forever. But look at the present day. Right now, to our south, the Red Sea is rifting. It is a young, embryonic ocean, and it's widening by 2 centimeters a year. Give it another 50 million years into the future, it might grow to rival the mighty Tethys itself, only to one day suffer the exact same fate, crushed into its own towering mountain range.
You carry the carbon of ancient plankton in your daily life, and you hold the history of a tropical sea in your perspective. The rocks, remember, are shared, deep-time history, and the ground beneath us is constantly writing the very next chapter. So I want to leave you with this. What vanished world are you walking on right now?
If you enjoyed this journey through deep time, like, share, and subscribe, and join us